Welcome to our channel Circuits Analytica. In this video, we will be discussing about Kirchhoff's current law. Kirchhoff's current law, or KCL in short, states that algebraic sum of currents entering a node is equal to algebraic sum of currents leaving the node. In other words, according to KCL, for a node, algebraic sum of currents is equal to 0. Kirchhoff's current law is also called as law of conservation of electric charge. To apply KCL at a node, let all currents entering the node are considered as positive and let all currents leaving the node are considered as negative. Mark the polarity of each current associated with the node. Equate total incoming currents to total outgoing currents. Mathematical representation of KCL. Let us consider a simple network with n number of resistors connected in shunt and a current source Is applied to the shunt combination of n number of resistors. The resistors are denoted as R1, R2, R3, etc. Rn. The input current Is is connected between node P and node Q. Resistors R1 to Rn are also connected between node P and node Q. At node P, there is only one incoming current and there are n number of outgoing currents. For a node, identify the incoming and outgoing currents. So let us consider node P. For node P, identify the incoming currents and outgoing currents. For node P, there is only one incoming current Is and the other currents are outgoing currents. There are n number of outgoing currents IR1, IR2, etc. to IRN. So according to KCL, we can write total incoming currents is equal to total outgoing currents. That is, Is is equal to IR1 plus IR2 plus IR3 plus etc. plus IRN. Find an expression for IR1, IR2, etc. Let V be the potential difference between node P and node Q, or V is the voltage across each resistor, resistance R1 to resistance Rn. So current IR1 is equal to V divided by R1. IR2 is equal to V divided by R2. Similarly, IRN is equal to V divided by Rn. So this is the application of Ohm's law. According to Ohm's law, voltage across a resistance is proportional to current flow through that resistance, or V is equal to I into R. Therefore, we can write I is equal to V divided by R. To find current flow through a resistance, if voltage across resistance and resistance value is known, we can write current flow through a resistance is equal to voltage across the resistance divided by a resistance value. Therefore, we can write IR1 is equal to V divided by R1, IR2 is equal to V divided by R2. IRN is equal to V divided by Rn. Therefore, we can write according to KCL, Is is equal to V divided by R1 plus V divided by R2 plus etc. plus V divided by Rn. Thanks for watching Circuits Analytica. Enjoy learning.